Hi and welcome to this new video about Apache Spark Structure Streaming new features. So today I will focus on Apache Spark Structure Streaming 3.2.0 and show you what changed for Apache Kafka source. So to start the demo, I will as usual, I will start an Apache Kafka broker. And I will create my test topic called Kafka changes. So I will now start the producer and show you the first demo code, which looks like that. In this code, I would like to show you how you can configure Apache Kafka source and more exactly how to use a new feature of customizing the behavior on data loss. So the data loss will happen when you try to read the offsets that don't exist anymore in the topic. So as you can see in my case, I have quite big number and obviously it's not there. So the default configuration for that property is error, meaning that whenever our use case happens, Apache Spark will fail the processing. So let me just start it to show you that fact. So as you can see, you have our error for this configuration, which obviously doesn't work because we don't have any data in our topic. So let's see now what happens for the latest scenario. So globally, you will see that for that specific use case, Apache Spark Kafka connector will go to the latest available offset and continue the processing. So you can see that we have our micro batch, and just to show you, I will maybe produce one record, and you should see that we have it here. So that was for the first feature. The second feature is about min offsets per trigger. So something that you can use to configure the minimal amount of data to process in every micro batch. So Spark will trigger the micro batch either after accumulating 5 records, at least 5 records, or after 1 minute if there is no 5 records accumulated yet. So I will start this and show you this feature. So we have our first micro batch, and now I will produce 5 records. And normally you should see that the micro batch triggered. Now I will do something slightly different and produce only 4 records. So I will do maybe 1, 2, 5. So you can see that there is nothing happening. And if I add a new message, so the 5th message in my list, you can see that Apache Spark triggered the processing for that configuration. So that was the second feature. So let's see now the next feature, which is the starting timestamp. So the starting timestamp is a property you can use to start processing data from all partitions at the specific timestamp. So globally here I will try to process data from 5 minutes ago, and you will see that I will be able to consume the data I produced before. So the 5 in my min offsets per trigger demo. So okay, sorry, I made a typo here. So let's restart it, and you should see that it will work well in that scenario. And you can see that I have my records I have produced in the previous demo, right from all partitions at this specific timestamp. And to terminate, I will show you the new metrics. So here I will execute a sample code, and I introduced and I added some latency simulation inside this mapping function, because every time I will process a record, I will sleep for 5 seconds, and you will see that the data and the offsets will accumulate, and we will use this fact to demonstrate that fact directly from the logs. So let me just get the logs path and start this code right here. Okay, the code has just started, and I will need to add some new records, just a lot of them, to show you this feature. So we are not processing anything yet, but we probably have something in the logs about the offsets behind the latest available offset for processing. So here we can see that we have 35 offsets to process, and you should see that this number will decrease in every microbatch. So here we have 33, and soon we should see 31. So that's one of the new metrics added in this Apache Spark 3.2.0 version. And if you want to discover other changes in structured streaming module, I invite you to the article which is linked in the description of this video. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.